Hi there, welcome back. We're going to move on to the next section, lesson 1.2. But first, I have a joke for you. What types of meals do math teachers eat? Are you ready? Square meals! Woohoo! And we are going to be talking about squaring and raising to the third power and the fourth power, because today we're going to move into exponents and order of operations. So let's go ahead and get started. And here we go. Lesson 1.2, objective day 1. I'm going to review the concepts of exponents. So we're going to kind of just go over briefly what makes up an exponent or an exponential expression. And I'm going to review the order of operation rules to help me correctly simplify expressions with multiple grouping symbols. All right? So here we go. All right. Remember in lesson 1.1, we did prime factoring. You may have noticed that certain factors or certain numbers were listed more than once. All right? Maybe numerous times. Well, it often becomes necessary in higher math to be able to write those reoccurring numbers, the product of those reoccurring numbers, in exponent form. So let's look at the number 81. If we were to write it in its prime form, I'm going to do my highlighter here real quick, in its prime form, 81 would be written as 3 times 3 times 3 times 3, all right? That's the same as saying 3 to the fourth power. The 3 is what we call the base. The 3 is the base. It's the number that is being multiplied by itself, all right? The natural number exponent, this number in green, that's the exponent, and it tells how many times we have to multiply the base as a factor. Okay? In this case, it tells us 4. We have to multiply 3 4 times. Okay? An exponential expression is any number or variable written with an exponent. So 3 to the fourth is the exponential expression of 81. It has a base of 3, this is the base, and it has an exponent of 4. That's the exponent. So let's try this. Well, that was bad. So let's try this. 2 to the fifth. What's the base? The base is 2. The exponent is 5. Its value is equal to 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is equal to 32. That's the value of this exponential expression. These two things are equivalent. 2 to the fifth is equal to 32. Some important ideas to keep in mind. If you have a number raised to the first power, it is simply that number. So 5 to the first is just equal to 5. 1/2 to the first is just equal to a half. 10 to the first is equal to 10. -3 to the first is equal to -3. Notice how I put parentheses around that. If an exponent is not expressed, it's not there. It's not there. It's not written. Okay? Not written. Then it must be an exponent of 1. So if you see 3 and they ask you to write it in exponential form, that's equal to 3 to the first. Right? Also, keep in mind that when you square a base, it's not the same as doubling. 4 squared is 4 times 4. All right, that equals 16. But doubling is multiplying by 2. That's what doubling means, multiply by 2. 4 times 2 is 8. You see how they are not the same thing? Similarly, with cubing or raising to the third power, it's not the same as tripling, all right? 4 cubed is 4 times 4 times 4. That's what equals 64. But tripling is taking 4 and multiplying it by 3. So that's times 3. Quadrupling would be times 4. Okay? Find the value of each exponential expression. All right? So we have 5 squared. Well, that is the same as 5 times 5. 5 times 5 is equal to 25. This is the value of this exponential expression. 6 cubed is 6 times 6 times 6. That is 6 times 6 is 36, times 6 is 216. This is the value of this exponential expression. You try C and D. Don't let the fraction fool you. Just multiply it together that many times. When you're done, come back and check your work. All right, welcome back. 2 to the 5th. Well, that's 2 times 2 times 2 times 2 times 2. Right? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's the value of 2 to the 5th. 2/3 squared is nothing more than 2/3 times 2/3. Right? We know how to multiply fractions. We did it. We multiply our tops together and then we multiply our bottoms together. So 2 times 2 is 4. 3 times 3 is 9. I cannot reduce, so 4/9 is the value of 2/3 squared. Now, order of operations. This really ties in biblically. Just as our universe is a complex system working together to bring glory to God, math problems are complex when they involve more than one operation. Because God developed order in the cosmos, there exists a created order by which we combine numbers. Mathematicians named it order of operations. Oops, need to get my highlighter. Order of operations. Okay? You might also want to think of it as kind of like rules of the road. You had to take a driving test so you knew the rules of the road so you wouldn't crash into anybody and hurt anybody. Well, these are like rules of the road, okay? Rules of the universe, the mathematical universe. Order of operations. You want to focus on inside any grouping symbols. Grouping symbols are parentheses. They're brackets, or they're a big fraction bar, all right? So inside any grouping symbol, you want to apply the following order. You want to evaluate or value any exponents. Once you have that done, you want to go back and look and do any multiplication or division in order that they appear from left to right. So if division were to appear as you went from left to right, you would do division first. If multiplication appeared first as you went from left to right, you would do multiplication first. And then finally, you're going to do addition or subtraction in the order that they appear from left to right. So you're going to have to multiply before you add. And before you do that, you're going to evaluate all your exponents. Okay? Keep in mind that once, or if no grouping symbols appear from the beginning, you just start with step 1. Okay? If no operation is indicated, then it's implied multiplication. This would look like 2, let me move that to my pen, 2 times 5. That could be written as 2 parenthesis 5. That implies multiplication. A lot of times you'll see it as 3x. That means 3 and x are being multiplied together. So that's what that means. Use the rules of operation, the rules for order of operation to find the value of each expression. All right? Do I have any grouping symbols? Nope. Then I'm going to start with step 1. Do I have any exponents? Nope. So now I'm going to move to step 2. Do I have multiplication? Yes. Or division? Yes. So I'm going to do that first. So I have 4 plus, and then I'm going to multiply 5 times 6. All right? Okay? Now I go back and I look and I say, do I have any addition or subtraction? Yes, I have addition. And there's my final value of that expression. I used my order of operation to find the value of that expression. All right? Let's try B. All right? I have grouping symbols. So now I work on the inside first. Do I have any exponents? No. So I don't have to worry about that. Do I have any multiplication or division? No. Do I have any addition or subtraction? Yes, I have addition. So I have 9 times 17. All right? Now I've cleared that out, so that's the equivalent of that, right? A number inside a parenthesis can just be released, okay? And 9 times 17 is 153. All right? Okay, let's go over example C. I have 6 times 8 plus 5 times 2. Start at the very top. Do I have any grouping symbols? No. Do I have any exponents? No. Do I have multiplication or division? Yes. So now I need to perform them as they occur from left to right. 6 times 8. My leftmost one is multiplication. What is 6 times 8? 48. Plus 5 times 2. That's 10. Now I can add 48 plus 10 is 58. All right? Now, example D is much more complicated. I have grouping symbols, I have exponents, so let's just start at the top. Do I have a grouping symbol? Yes. So now I'm going to clear up everything inside this grouping symbol first. And I do that by looking for exponents. Do I have an exponent? Yes. I have 5 squared. What is 5 squared? 25. Plus 6 times 2. And then I'm just going to copy this down. Okay? Now I'm still inside this grouping symbol, right? And I have 25 plus 6 times 2. What do I do first? Well, I don't have any exponents, so now I have to multiply first. So I have 2 times 25 plus 12. And then I'm going to copy down my other terms, factors. Okay? I still have this grouping symbol, but I can add it together now. So I have 2 times 37 plus 7 times 3 squared. Now I have no more parentheses or grouping symbols. So now I start and I evaluate my 3 squared. Why? Because it has an exponent. So I have 2 times 37 plus 7 times 9. 37 times 2 is 74. Plus 7 times 9 is 63. And now I can just add them together and I get 137. Okay? It is just imperative. I know it's a lot of steps, but it's imperative while you're learning this and reviewing this and shoring up those foundations that you might be missing, that you follow it step by step. All right? Okay, why don't you try E and F on your own, and then press pause, try them on your own, and then come back. All right, welcome back. I'm going to show you how to solve example E. I don't have any parentheses, but I do have an exponent, so I'm going to apply that exponent first. So I have 9 minus 2 cubed is 8 plus 5. The next thing I look for is multiplication and division. I have neither of those, so I can skip that. That really doesn't apply. Now I apply, I do addition and subtraction in the order that they appear. So I must go 9 minus 8 is 1 plus 5 is equal to 6. So the value of this exponential expression is 6. 72 divided by 2 times 3 plus 4 times 2 cubed minus 3 cubed. All right, I'm going to copy everything. I don't have any grouping symbols. All right, so what I'm going to do is I have to focus on the exponents first. So I'm going to copy everything up until that point. Divided by 2 times 3 plus 4 times 2 cubed is 8 minus 3 cubed. That's 27. All right. Now I have to look for multiplication and division and do them in the order that they appear from left to right. So that means I have to divide 72 by 2 first, and that gives me 36 times 3 plus 4 times 8 is 32 minus 27. I have one more multiplication here. Okay, 36 times 3 is 108 plus 32 minus 27. Right? So 108 plus 32 is 140 minus 27. That's a 3, that's a 3, that's a 1, is equal to 113. If you have more than one nested grouping symbol, start with the innermost one first and work your way out. Let's look at example A. I have 2 and then I have a bracket, 8 plus 3, and then I have a parenthesis. This is what it's called nested. 6 plus 5. All right, so I'm going to start here at the 6 plus 5 first. I'm going to rewrite everything as it is. So I have 2 bracket 8 plus 3 times 6 plus 5 is 11, so I'm just going to write it as times 11. Okay. Now I have to clear out all of this. I have to do these operations. All right. So I have 2 bracket. I have 8 plus 3 times 11. All right. My order of operations says I have to do the multiplication first. So I have 8 plus 33. Now I add 33 and 8 together, and I get 2 times 41, which is equal to 82. Okay, now example B, this is like nesting because we have this big division sign in here. So I'm going to simplify my numerator first, and then I'm going to simplify my denominator. More than first or second, it's separately. You want to simplify them separately. All right. So in my numerator, I have 4 parenthesis 5 plus 3, and then plus 3. So I have to work this out first, and I get 4 times 8 plus 3. Now in my denominator, I can go 2 times 3 is 6 minus 1. Now look, 4 times 8 plus 3. What do I have to do first? Well, I have to do multiplication before I can do addition. So that gives me 32 plus 3. In my denominator, in the bottom, all right, I only have one operation left, so I can just simplify that. 6 minus 1 is 5. And so that equals 35 over 5. Now, we want to make sure we reduce, right? Does 5 go evenly into 35? Yes, it does. So that equals 7 over 1, which is 7. These are the homework problems that we're going to be working on tomorrow in class. So go over the notes again if you need help with the order of operations. Listen to it another time if you need to. Otherwise, I'll see you in class. Thanks for listening. Bye.